I wanted to play that because Carl Jenkins comes from the very same part of the world that I come from. And his music always makes me feel very relaxed. And because, of course, the pictures that were showing space. So we will be talking a little bit about that as well tonight. Now, Manvantara and Pralaya, or why our universe exists on a knife edge. This knife edge is nothing to do with politics or wars. It's about the universal law of periodicity. Manvantara, Sanskrit, Manu is man, and Antara is duration, so it's a period of existence. Pralaya is also a Sanskrit word, and it means dissolution, or a period of non-activity or non-existent. And universal law is derived from Hermetic philosophy in the Kabbalion and deals with fundamental principles that govern all existence, encompassing both physical and metaphysical realms. Scientists now think that there are about 2 trillion galaxies in the universe, and there are 200 billion stars in the Milky Way. Let's look at some of the forces in the branches of physics. This was from the 60s. We had the electromagnetic and the weak force, which together form the electroweak. We had the strong force and the force of gravity. Now, the Big Bang is a scientific theory about how the universe started and then made the stars and galaxies we see today. The theory claims that the universe began as a very hot, small, dense superforce called a singularity. This superforce was the mix of the 4 fundamental forces of physics. At that time, there were no stars, no atoms, no form, no structure. Now, in Theosophy, another term for forces is the elemental kingdoms, air or wind, earth, fire, water. They're the first 4 elements, and then Akasha. These nature spirits have a great effect on our karma. The unconscious, photographic and automatic elemental kingdoms assumes the complexion of the human race. And I've just added, because I've seen it written, be careful what you put out. Again, but first, there were 3 elemental kingdoms. In terms of life waves, there are 7 on this planet, in ascending order, first, second, and third elemental. And these are the forces of nature, such as electricity and magnetism. And then we have the 4 physical waves, the mineral, plant, animal, and human. And again, we have first, second, and third, thank you. First, second, and third elemental, then the mineral, the vegetable, the animal, the human, and then, of course, we go on to the divine. Each plane of nature is Akasha in one of its 7 states. Besides Earth, the lowest state, the next lowest is termed the astral light. This is the invisible region that surrounds our globe, as it does every other, and it's a very subtle essence, visible only to clairvoyance. It's been described as the great picture gallery of nature, because on it is indelibly impressed every act and thought that occurs in the physical or psychic realms. As it interpenetrates the grosser forms of matter on our plane, only people with clairvoyant sight are able to pass beyond the external opaque form, which we can all see. And that's where Edgar Cayce had his readings from. Now, speaking about physics, what is a singularity? Well, a gravitational singularity exists in the center of a black hole. It's a one-dimensional point that contains a huge mass in an infinitely small space, where density and gravity become infinite and space-time curves infinitely, and where the laws of physics as we know them don't operate. 4th of July 2012. These people are in all over Europe, in America, but they're not celebrating Independence Day. They've spent $13.25 billion on something. And after they've spent it, they're all cheering like crazy. This is a 7-foot statue donated by India to CERN in Switzerland. It's Shiva, one of the Trinity of Gods in Hinduism. Shiva was the absolute destroyer of ego, of ignorance, and of evil, and allows for transformation and rebirth to happen. Now, I'll come to why India donated this to Switzerland later. So, what had happened on the 4th of July in 2012? Well, the Higgs boson was discovered, and that was the particle that they'd been looking for so long. But 19 years before the Higgs boson was discovered, a book was written. They called it the God particle. And they wrote, if the universe is the answer, what is the question? It was published in 1993 by American physicist Leon Lederman with Dick Tracy, and he explained why he'd chosen this title. The boson, or particle, is so central to the state of physics today, so crucial to our final understanding of the structure of matter, yet so elusive that I've given it a nickname, the God particle. Why the God particle? 2 reasons. 1, the publisher wouldn't let us call it the goddamn particle, although that might be a more appropriate title, giving its villainous nature and the expense it's causing. And number 2, there's a connection of sorts to another book, a much older one. He began to quote, "In the beginning, God created the heaven and the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, 'Let there be light.' And there was light." So, of course, he was quoting the Bible. And what these physicists have been trying to do is discover how everything started, or how all the physical things started. Now, if we go back to CERN, which stands for Conseil Européen pour la Recherche Nucléaire, which is the European Council for Nuclear Research, they have a machine there called a Large Hadron Collider. A hadron is a composite particle, just like a proton or neutron, with no intrinsic spin. And it's made of quarks that are held together by the strong force in the same way that molecules are held together by the electromagnetic force. After 2012, the 4th of July will be remembered by many people for something other than US Independence Day. And that's why Shiva's statue is outside the entrance to CERN. Shiva the destroyer, they were trying to destroy particles there. Now, can we take that away again? Oh, good. Okay, meet Dave. At work, Dave likes to smash things up to see what they're made of. And that's why Shiva is outside the entrance to CERN at street level. Dave's home is in France, but his office is in Switzerland. He takes a lift to a regular office with papers, computers, phones, everything else. But down below Dave's office, he can go down to a basement that is 100 meters deep. Well, that's like a 33-story building tipped underground. CERN is the largest machine ever made. It weighs 40,000 tons. It took 3,000 scientists and engineers 20 years to design, to build and get running. And this shows the large camera that records the collisions at almost the speed of light. It's called a solenoid compact muon collider camera. Solenoid really just means like a coil of wire shaped like a cylinder and acting as a magnet when currents pass through it. And a muon is just like an electron, but 200 times heavier. Now, the camera is a general purpose detector at the Large Hadron Collider. It has a broad physics program that includes searching for extra dimensions and particles that could make up dark matter. Now, very quick reminder, parts of an atom. In the nucleus, we have protons and neutrons. The protons here have a plus sign and they're colored green. The neutrons are there to stop the protons from pushing each other out because similar charges repel. Around the nucleus, we have the electrons in specific orders, 2 in the first and so on, so many more in each coil. And the number of electrons, which are negative charges, must be the same as the number of protons so that they balance. So let's see the next thing. If we look at CERN or parts of CERN that are underground, a large ion collider experiment is what's going on there, and that's called ALICE, if you look at the first letters of each word. And there's a toroidal Large Hadron Collider apparatus. And if you look at the red letters there, that's commonly called ATLAS. So they have ALICE and ATLAS there, and they're 2 of the world's largest. Well, the Hadron Collider is the world's largest and most powerful particle accelerator. It consists of a 17-mile ring of superconducting magnets with lots of accelerating structures to boost the energy of the particles along the way. And it's between 50 and 175 meters below the ground. ALICE, it's a kind of a camera. Its main aim is to study head-on collisions between heavy nuclei. At first, they use mainly lead-on-lead at the top energy of the Hadron Collider. But it's a toroidal or donut-shaped large apparatus and is one of the 7 particle detector experiments that's going on. At top speeds, these particles could circle the entire Earth 7.5 times in 1 second. That's how fast they're going. And they have to go that fast in order to explode them when they crash. Now, quarks. Protons and neutrons are made of quarks. There are 6 different kinds, and they go in pairs. There's the up and down, and those are the only ones used in protons and neutrons. But there's charm and strange, and top and bottom. So these 6 different sorts of quarks come in pairs of opposites, as I said, and protons and neutrons are made up from quarks, up quarks and down quarks. In a proton, we have 2 ups and a down, and the charge of an up is 2/3, and the charge of a down is -1/3. So the proton would have 2/3 up, 2/3 up, and then 1/3 down. That averages out to +3/3, which is a positive charge. The neutron has 1 up with a charge of 2/3 and 2 downs, each with a charge of -1/3. So altogether, the neutron just has no charge at all because the 2/3 up is balanced by the -1/3 and -1/3 down. Right, those are the ones that make hadrons. And a hadron is just a word, a common word for a proton or a neutron. Right. There are other subatomic particles too that are leptons and gluons, but we don't really need to bother about these for now. Gluons are just a bit like glue. They keep all of the particles together. They kind of stick them together. Now, sometimes protons have more than 3 quarks, but the number must be odd. They must just have the right combination of up and down, but they can be pairs, like we could have a top and a bottom pair there, or we could have 5 top and bottom pairs skimming around the nucleus. We could have charm and what's it called? Charm and strange, but they must be in similar numbers. We could have 7 charm with 7 strange. They must balance each other. And they kind of skim around the nucleus as well, but we don't hear much about them. So everything in the entire universe is made by joining together combinations of the 3 particles, which are up quarks, down quarks, and electrons, which is like saying protons, neutrons, and electrons. Of course, they're joined by using special forces. Sometimes Theosophy calls the elementals. Yes, everything, including aliens and beings outside our own galaxy too. Everything is made from these particles. But when the smallest particles are smashed together, a very weird thing happens. Energy is equal to mass times the speed of light squared. This was something that Einstein taught us. Now, c squared, or the speed of light squared, if you multiply it by itself, it comes to 34,700,983,524 miles per second. So the c squared can transform energy into a different sort of matter, which is way bigger, because if we take a little bit of matter and multiply it by 34.7 billion, we're going to have a huge amount of energy. Now, in the collisions, we found a few different sets of particles or building blocks, and they look very much like the original quarks and electrons, but they have a different charge. Plus becomes minus. These are called antimatter versions. They're also found in different particles, ones that don't exist in our universe anymore, but can be made in the laboratories. But they did exist at the time of the Big Bang, 14 billion years ago. So just by smashing things together, we can almost travel back in time and see what the universe was like in its very early days. But nature guards her secrets about these early days only too well. Only about 1 in 100 billion collisions gives up some clue as to what the beginning universe was like. So we need to produce many, many, many collisions, and the CMS camera is only 100 megapixels. Well, an iPhone X has 12 megapixels. However, this CMS camera can take 40 million pictures a day, and that's for 200 days of the year. So back in 2012, all the fuss and celebrations were all about a newly discovered particle called the Higgs boson, also called the God particle. So after looking at several trillion pictures of nothing happening, when the students go in their spare time and they pay to check all the pictures, after all this time, it shows a collision with all kinds of things flying out. And there it is. That's why the celebrations were, it's the God particle. Peter Higgs was a British theoretical physicist, Professor Emeritus at the University of Edinburgh, and he got the Nobel Prize for physics for discovering the Higgs boson. And it was called that because prominent Indian physicists say that naming the God particle boson after the Indian scientist Satyendra Nath Bose is the biggest honour. And that's why India presented the huge statue of Shiva to CERN. So Shiva the Destroyer was in appreciation of recognizing the work of an Indian physicist. And of course, they had to destroy subatomic particles to reach the God particle. And here's Britain's Peter Higgs with Belgian Francois Engler when they won the Nobel Prize. I'm not going to go much into that. Many scientists believe that at the time of the Big Bang, there were equal amounts of matter and antimatter created. But they annihilate each other on contact. All the matter and antimatter should have destroyed each other a billionth of a second after the Big Bang. But a very small bit of matter must have survived, as a tiny bit more matter was created. Otherwise, we wouldn't be here. Nothing would, unless our universe had been created out of antimatter particles. Maybe our world would have been like stepping through the mirror, who knows? So the aim of the Large Hadron Collider is to find out more about antimatter. Now, looking at primordial matter and antimatter, there we have 10 billion and 1 particles or whatever of primordial matter, and we have only 10 billion of antimatter. So there's one more particle. If those particles have to join with each other, we're going to have one left over. The ones that join will annihilate each other, but we'll be left with one particle of primordial matter. But what really happens when protons collide? Protons, as we know, are quarks bound together by gluons, and in a head-on collision between two protons, it's the quarks and the gluons that they're made of which actually collide. And as we've seen, the new particles are usually much heavier than the original colliding particles with huge energy, thanks to Einstein saying that the energy is mass times the speed of light squared, which is mass times 34,700,000,000. So the big surprise of July the 4th, 2012 was that there was no really big surprise. Theoretical physicists had said that the Higgs boson was a clever explanation of how fundamental particles gain mass. But that seemed unsatisfactory and incomplete because too many questions were unanswered. The Higgs boson didn't share the symmetry, the beauty, the elegance of the rest of the elementary particle work. So most theoretical physicists didn't believe that the Higgs boson could be the whole story. They'd expected new particles and phenomena accompanying the Higgs boson, but the measurements coming from it didn't show any new particles or phenomena at first. However, they said that by 2015, the increased capacity of the machinery would almost double the energy of the colliding protons and new things would be found. The goal in 2016 to 17 was to prove that the decay exists, and based on this knowledge, to measure the Higgs particles' properties more accurately. Measuring the decay is extremely important for the researchers so that they can explain the short lifespan of the Higgs particle. Measurable deviations from standard theory's predictions could point to so-called new physics, which reaches beyond the standard model. And here, this is in 2018, after years of its discovery, the Higgs boson has at last been observed decaying to fundamental particles known as bottom quarks. Now, the bottom quark is the heaviest of all the quarks. And so a Higgs boson, or the God particle, when it decays, it becomes a pair of bottom quarks. But going back to 1/10 of a billionth of a second after the Big Bang, something happened. Space-time underwent a phase transition, just like water when it turns to ice at 0 degrees. But during this phase, empty space became filled with a substance we now call a Higgs field. It's invisible. We can't see it, but it does have a physical reality, just like the air we breathe, and it surrounds us all the time. Now, this shows the approximate percent of each type of matter in the universe according to CERN. So this 19/20ths of everything around us that we cannot see or touch, in the physical at least. We're only aware of that little green slice, 5%, the 1/20th of it. But think of our sevenfold human constitution with the other planes all around us. That's the other 19/20ths. The universe comes into being from within outwards. It exists on different levels in the inner worlds. From the worlds of ideation, it proceeds as archetypes, becoming more and more defined and substantial as it passes down, now as prototypes through the formative planes. Finally, it's projected into objectivity on the physical level in the forms we know. The process is cyclical. All things come and go in due season, governed by those laws that are aspects of the one universal law. Now, this is the Theosophical point of view. The Big Bang refers only to the material plane, to the physical matter of the cosmos. It says nothing about the inner planes, such as the psychic or spiritual planes. The ancient wisdom says that physical matter is the outward effect of several finer states of existence, from the purely spiritual at the highest level of being to the crude energy structure underlying physical particles. So, is a black hole the mark of a pralaya? Before the creation process begins, there is no thing at all, nothing, but there is potential. This means potential consciousness and potential matter. The eternal father-mother, maybe in a state of non-being. Wrapped in invisible robes and each other's embrace, slumbering for 7 eternities. This is a pralaya, resting, withdrawn from activity. Mula Prakriti, or root matter or nature, is asleep on the left, while Parabrahman, unmanifest consciousness or spirit, sleeps on the right. Creation is cyclic in 2 distinct phases, conscious and unconscious, activity and rest, being and non-being, manifest and unmanifest, actual and potential. This potential is in us, yet in itself it is nothing until we act to bring it into being. The ancient teaching says that the first thing that happens is a waking up or a rising of the creative purpose into space. Parabrahman and Mula Prakriti are opposite poles of the divine or absolute in its state of rest in between creations. Spirit sleeps, wrapped in its veil of virgin matter, brooding through the indeterminable aeons of pralaya. When it wakes up, it's within the virgin space and in so doing impregnates it with the seed. Virgin space is the darkness of Genesis that was on the face of the deep. It is matter with its 3 conditions in total balance, and the 3 conditions are motion, inertia, and rhythm. When spirit wakes up in space, this balance is broken, and ceaseless activity is the result. Who are the Mahatmas, or the brothers as they like to be called? Master Maurya, Master Kutumi. In letter 90 from Kutumi to Hume, the following is recorded. There are some modern philosophers who would prove the existence of a creator from motion. We say and affirm that the motion, the universal and perpetual motion that never ceases, never slackens nor increases its speed, not even during the interludes between the pralayas or nights of Brahma, but goes on like a mill set in motion, whether it has anything to grind or not. For the pralaya means the temporary loss of every form, but by no means the destruction of cosmic matter, which is eternal. We say this perpetual motion is the only eternal and uncreated deity we are able to recognize. Now, in Theosophy, we are familiar with the three outpourings. How did it start? From Deus, which is will, chaos, wisdom, logos, activity. I'm not going to go through the whole thing. If you've done the Theosophical Diploma, you will know all of this anyway. But reflecting on that, Fohat is the first thing to act, and Fohat drills holes in space. The third logos, it digs holes in the raw substance of space, and these holes are like bubbles containing the fire of Fohat as it wells up within it. All the space that has been circumscribed for the new creation is soon filled with these bubbles of fire. Next, Fohat works in a spiral motion, drawing these bubbles into strings, which it links in the form of a double helix. Well, this is incredibly like the form of the DNA molecule. In this way, the first plane of matter is formed. It's called the logoic plane due to it being the plane of manifestation of the logos. This is how the first plane of matter, called the logoic plane, is formed. We're going to come back to some measurements on this a little while later. There are 7 subplanes of increasing density. Fohat takes the basic worlds and combines them into deeper combinations, spinning so they interlock, forming heavier material. This is a matter of the next plane, the monadic. By repeating this process of combining and recombining, Fohat produces ever more dense and heavier matter or planes until all 7 are organized, each with its set of 7 subplanes, from the logoic down to the physical. Now, the second aspect of the triple logos goes to work. This is the form builder, or the dual aspect, the father and mother in nature. It's the life within matter, and it inhabits the newly established planes. Right, I'm not going to go on too much about that because we all know the theosophical one. After reaching the physical plane, the second aspect returns back upwards to its divine source, following the path of return. And the path of return is shown on the right-hand side. And then we have the path of return is shown on the right-hand side, establishing the mineral, vegetable, animal, and finally the human kingdom. At the point of transition from the animal to the human kingdoms, the third outpouring takes place. This is the action of the first logos, the will, the originating purpose of the creator. So flashing down through matter of the planes to meet the returning life wave at the higher mental level. It illuminates man's mind and gives him self-conscious awareness. So all three aspects of the triple logos now follow the path of return through the Buddhic, Atmic, and monadic levels. Then Fohat, the third in the fire aspect, returns as the Kundalini force working through the etheric spinal channels, the chakras, and so on. So, remembering the dark stuff, the dark energy and dark matter, that's all the red and blue. The part we're aware of every day, everything we have been aware of, is that little green slice. But let's see what all this dark stuff is, according to the ancient wisdom teachings, because CERN doesn't really know. Today's physicists only deal with the material universe, but even the scientists now agree it's only a tiny part of all that is. Akasha in Sanskrit means ether, or the primordial root or spatial substance of the universe. Akasha manifests after the long night or pralaya of the universe. It forms gradations of this substance throughout the planes of nature, causing our physical globe to be enveloped in the lower of these grades, called the astral light. Akasha is the subtle, supersensuous, spiritual essence that pervades all space. I'll say it again. It's the subtle, supersensuous, spiritual essence that pervades all space. Just as force or energy needs a vehicle for its expression, so spirit also requires a vehicle through which to manifest. The lower regions of Akasha, immediately above the gross physical plane, is called the astral light. It's the invisible region that surrounds our globe and everything in it, and corresponds to the subtle vehicle or double in man, the Linga Sharira. Everything that takes place in the physical, psychical, and mental realms is recorded in the astral light. It's thus the storehouse of memory, both in the cosmos and in mankind. Now, according to the physicist, this dark energy matter is the Higgs field. So let's get back to what the science says about it. Fundamental particles interact with the Higgs field, gaining energy in the process. This intrinsic energy is what we call the mass of a particle. By discovering the Higgs boson, it's been proven that this substance is real because it's the stuff that the Higgs boson is made of. And this is the essence of the story. Now, a man called Pierre Teilhard de Chardin, he said, matter is spirit moving slowly enough to be seen. Now, he was a Jesuit priest and a philosopher and paleontologist. He worked on the Peking man, but he passed away in 1955. And that was his theory at the time. Matter is spirit moving slowly enough to be seen. By studying the Higgs theory, theoretical physicists discovered, by the power of mathematics, that the Higgs field doesn't necessarily exist totally in the form that we observe today. Matter can be solid, liquid, gas, plasma, so the Higgs field that fills all space-time can exist in two states. This is very important. As well as the regular state, there could be another, where the Higgs field is billions and billions of times more dense than the one we see today. And this could pose a potential problem, or scientists feel it does pose a problem. We can now see that the 7 planes which constitute the cosmos are in fact Akasha and 6 differentiations of it, and that this same Akasha, known to the ancient philosophers as ether, not the modern ether with all the mysterious and occult properties, but the ancient one, contains in itself the germs of universal creation. Geoffrey Farthing speaks about this in Deity, Cosmos and Man. But Here we have the Higgs field in two states. So what's the problem? The mere existence of the Higgs field in another state does pose a problem, because according to the laws of quantum mechanics, it is possible to have transitions between two states, even in the presence of an energy barrier separating the two states. This phenomenon is called quantum tunneling. There's Peter Higgs. He says, quantum tunneling, throw a ball against a wall, it'll bounce back to you, catch it. Throw it against the wall again, keep doing it, you keep throw, catch, and suddenly it goes through the wall. Because of quantum tunneling, someone could disappear from a room and appear somewhere else, say in the next room, practically penetrating the wall. I can't do it. Now, the top scientists at CERN are saying it's a reality and has been observed scientifically under many systems. Now, this is the kind of information they're not going to give out to the general public. But the Mahatmas, or brothers, as they love to be called, were very adept at doing this. Quantum tunneling could have been a method of delivery of the Mahatma letters. If, say, Kutumi were holding a physical letter in his hand and through the power of his mind was able to transfer that letter to a different energy field, say into the astral light, and instantaneously send it to a receiver who could then, either from his mind or from her mind, re-bring it into the physical, it could be sent instantaneously. Now, I do know from personal experience that when one is in the astral form, travel is almost instantaneous to very far places. I don't want to talk about it right now, but I can talk about it another time if anyone's interested. Now, how do we benefit from quantum tunneling? The tunnel diode, which is a component used in electronics, works thanks to quantum tunneling. A diode is a one-way valve for electricity, and it works because it goes into a different level of vibration. Back to the Higgs field. If the ultra-dense Higgs field existed, then because of quantum tunneling, a bubble of this state could suddenly appear in a certain part of the universe at a certain time. Well, an analogy is boil water and water will turn into gas. Bubbles of water turn into gas. In the same way, bubbles of an ultra-dense state could come into existence because of quantum tunneling. The bubble would then expand at the speed of light and turn the Higgs field from the familiar state into a new state. And this is a big problem. We might not realize this in ordinary life, but the intensity of the Higgs field is critical for the structure of matter. If the Higgs field were only a few times more intense, we'd see atoms shrinking, neutrons decaying, nuclei disintegrating, and hydrogen would be the only possible chemical element in the universe. And that's because it has only one proton and one electron. It's the only element with no neutrons. And the Higgs field in the ultra-dense field could not just be a few times more intense than today, but billions of times. And if space-time were filled with this dense state, all atomic matter would collapse. No molecular structures would be possible, no physical life. Physicists say no life, but physics deals only with the physical component. That's just a tiny part of all that is, as we know. This physical body is nothing compared with what's on the other side. So what is the fate of the Higgs field in our universe? Physicists ask if it's possible that the Higgs field could ever undergo a phase transition through quantum tunneling, Could our world be transformed into this nasty, ultra-dense state? In other words, what is the state of the Higgs field in our universe? To answer this, we clearly need to know the Higgs boson mass. Now, mass is another word for size or weight really. Now, the Higgs boson mass is 126 giga-electron volts or billion electrovolts, or it's 1/5 of a billion trillionths of a gram. Now, the next part is very important. This is so tiny when expressed in familiar units, but it's quite large in particle physics units because it actually equals the entire weight of a DNA molecule. When I said we'll come back to DNA, this is it. Thymine is a molecule of our DNA. DNA is made up of 4 nucleotides, and thymine is one of them. It's 5 atoms of carbon, 6 of hydrogen, 2 nitrogen, and 2 oxygen. That's exactly the same weight as the Higgs boson mass. If we look at the structure of our DNA, remember how Fouhat started to twist things around that looked remarkably like our DNA? And the Higgs boson mass is the same as the mass of one of these elements. We have cytosine, guanine, adenine, and thymine. That's an exclamation mark. Thymine. So they fit together in pairs. A is always with T and C is always with G. Scientists at CERN then computed the probability that our universe could maybe quantum tunnel into the ultra-dense Higgs state, and they found a very intriguing result. Their calculations show that the measured value of the Higgs boson mass is very, very special. It has just the right value to keep the universe hanging in an unstable situation. The Higgs state is in a wobbly configuration that has lasted so far, but will eventually collapse. Now, this is nothing at all to worry about, as you'll see. It explains a lot of theosophical things. So we are like campers who accidentally pitched our tent on the very edge of a cliff, and eventually the Higgs field will undergo a phase transition, and matter will collapse into itself. But quantum tunneling of the Higgs field isn't likely to occur in the next 10 to the power 100 years. Now that means 10 times 10 times 10 times 10, 100 times. We will all be long gone by then. Scientists at CERN are not only concerned about the infinitely small. They have cosmologists there, and they work with the infinitely large. And they say in about 5 billion years, our sun will become a red giant, as all stars do when they get old. And it will be as large as the Earth's orbit. And our Earth, of course, will be swallowed up. It'll be gone. But that's in 5 billion years, nothing for us to fret about. And in 1,000 billion years, if dark energy keeps on fueling space expansion at the present rate, we won't be able to see our toes, as everything around us will be expanding faster than the speed of light. We would hardly be around to see the Higgs field collapse. So everything will be expanding. So why is the Higgs mass so special? We want to understand the transition of the Higgs field because we want to address the question of why the boson mass is so special. Is it just to keep the universe at the edge of a phase transition? Theoretical physics always ask why, they don't ask how. They think that the why question gives them clues about the fundamental propositions of nature. And this why question opens up new universes, literally. It's been speculated that our universe is only a bubble in a soapy multiverse made up of a multitude of bubbles, and each bubble is a different universe with different fundamental constants and many different physical laws. There are probably many universes that are composed of antimatter. In this context, you can only talk about the probability of finding a certain value of the Higgs mass. Now, all of these things I'm reading, of course, they're not my opinion. This is all the stuff that's coming out of CERN. Now, the key to the mystery could be like what happens to sand dunes on a beach or in the desert. Some are very steep and others are shallow. But the typical angle is around 30 to 35 degrees, and the reason is simple. Wind builds up the sand and gravity makes it fall. The result is that the vast majority of slope angles are around the critical value near to collapse, 30 to 35 degrees in this case. Something similar could happen for the Higgs boson mass in the multiverse. In most bubble universes, the Higgs mass could be around the critical value, near the cosmic collapse of the Higgs field, because of two competing effects, just as in the case of sand. But scientists don't know the end of the story. They think only about the physical world, and to solve the mystery, they need more information. Just from one number, the Higgs boson mass, 126 giga-electron volts, or 1/5 of a billion trillionth of a gram. Now, for a summing up, I want to show you, just in a minute or two, a little bit about the God particle. So if you could just watch it, please.
The Higgs boson. You may have heard of it, but what is it? And what would the world be like if there were no Higgs boson? Well, then there'd be no world. Its particles wouldn't be able to stick together, and they'd just float around aimlessly forever. And where would that leave you? Nowhere. That's where. You wouldn't exist. But let's step back for a minute. Or rather, let's step inward. All objects in the world consist of matter, and all matter is made up of atoms. Remember that atoms themselves are made up of protons, neutrons, and electrons. And those particles are made of even smaller subatomic particles, such as quarks. Scientists have created the standard model of particle physics to describe these subatomic particles and how they interact with each other. The standard model is able to be applied to many things, including electricity, magnetism, and radioactivity. But the standard model had a hole in it. Scientists were unable to fully explain how these subatomic particles gained mass. This is where the Higgs field comes in. It is a field of energy that exists throughout all of space, and it is composed of Higgs bosons, which are elementary particles. All subatomic particles pass through and interact with the Higgs field. Some of these particles, like photons, whiz through and barely interact with it, resulting in very small mass. Other particles, like quarks, drag through and interact with the field a lot, which results in a larger mass. With this, the Higgs boson is able to successfully fill in the hole in the standard model. Now, you might be wondering how in the world scientists were able to discover such a thing. In 1964, a group of scientists, including Peter Higgs, proposed the idea of a mechanism that would suggest the existence of the Higgs particle. This idea helped encourage the eventual design and creation of the world-famous Large Hadron Collider, or LHC. The LHC is an enormous ring-shaped machine located in Geneva, Switzerland. It sends beams of charged particles whirling around in opposite directions through the ring, constantly whacking them to make them fly faster and faster until finally, wham! They collide, leaving tracks of subatomic particles that scientists can study. Collisions expose many types of subatomic particles, and on rare occasions, a Higgs boson can be seen. This event finally occurred on July 4, 2012, and researchers were finally able to put the elusive puzzle piece into place. So what are we supposed to do with this information? What can the Higgs boson do for us? And what kinds of things will it bring in the future? Some scientists speculate that this discovery will help them gain insight into dark matter, which they think accounts for 23% of the universe. Other scientists say that the discovery will allow us to produce new particles that could have practical uses. No matter what new discoveries this knowledge will bring us in the future, we know we can thank the Higgs field for allowing us to exist in this world. Thanks, Higgs boson.
Well, thank you for staying. I mean, this was quite something to listen to. So that's it for tonight. So thank you. Maybe we can see everybody now. No.
If you just stop the screen share, Pam.
Okay.
Yeah.
Well, yeah.
Wow. I don't know about anybody else, but my head's spinning. But
well, I'm afraid mine is as well. And I said to my daughters, why on earth did I even think about doing a subject like this? But I said I do it, so I've got to do it.
well done. I mean, what that shows a really impressive command of both particle physics and theosophy, which can't be a very common combination, I would think. And I think, you've really shown us how what the links are between physics and theosophy, and also brought me up to date anyway with quite a number of things. I did physics A level more years ago than I care to say, but half of the things you've talked about hadn't been even discovered then. So it's been a very useful session for me, I'm sure for other people as well. Are there any questions or comments or thoughts? Yes, Elizabeth, and then Pat. Yeah.
Yes, this isn't any sort of high-powered question, Pam. It's really simple, but thank you. That was amazing, and I just can't believe where you found all this information and those clips. They're fabulous. The last one was great, wasn't it? In particular, but I just wanted to know, when you were talking about quarks, you mentioned positive, negative, and something, or up and down. I don't know, and then you said charm and strange. What on earth does that mean?
Well, that's what they call them. There are 6 different kinds of quarks, and there's an up-down, top-bottom, charm, strange. Those are the names that the physicists gave to them, and they're just called by that. But the very important ones are the up and down ones, because they make the protons and the neutrons. But the others just come together in their pair, like a top has to be with a bottom, a charm has to be with a strange, and they race around in the nucleus as well. The nucleus is very haphazard. I used to think it only contained protons and neutrons, and I didn't even know what they were made of, when I was a kid, but it wasn't discovered, I guess. But if you think about the proton or the nucleus, of any element now, it's just quarks and gluons and I think ketones and different things. But they don't teach that in school because it's a bit above the heads of the children, I think, Anyway.
Well, that helps, Elizabeth.
Well, I've heard what you said anyway. It just seems it's a name that they thought up.
I think they've used rather idiosyncratic names. I think it's quite nice in the way they do that. It makes it seem more homely, doesn't it? Pat, you've got a question or a point?
A comment, not a question. My husband was very interested in quantum mechanics and particle physics and would read up the subject to a great depth and try and talk to me about it. And I couldn't really carry out that conversation. And I came to Theosophy after I'd lost my husband. He passed away about 10 years ago now. And I was just thinking as I was listening to that, oh, if only, because we could have had some wonderful conversations. So not only was it a very interesting talk, but quite an emotional one for me. But at least it makes me think that I'm sure that my husband and I will meet again and be able to have those conversations. Just absolutely fascinating. Thank you very much.
You're very welcome.
Well, that's lovely. Emotions not something I thought of in relation to this talk, but yes. Barbara, you've got your hand up there.
Yes, so I think we're coming to a place in quantum physics. Has been stated many times that a particle is also a wave, and a wave is a particle, and there. A particle may be just some vibration in a wave. So is this taking us closer to HPB's view of matter in the material world?
I think there's a question there for you, Pam.
What was I didn't get what the question was. Did you say, is
The
it
question-
taking?
So is quantum physics now coming closer to
Oh, is it coming closer to? Yes.
theosophy and
Yes,
HPB
yes, it is. Yes,
view
of course.
of the atom?
Yes, yes. I'm sorry, I missed that you were asking me. Is it? Yes.
Because just adding to that, I mean, one of the more recent developments in quantum mechanics is the concept of entanglement, where subatomic particles are linked, and it's been discovered that they're not just linked over very short distances, they're linked as far as you can get them apart, even in astronomical distances, which really underlines the interconnectedness of the whole universe, even at a physical level, which I think is quite astounding. Any other comments and questions? We've had quite a few thoughts in the messages. Julie says, "Thank you so much, Pam." Tuan, fantastic as always, Pam. I shall use this as a starting point to look more things up. Edgar, a wonderful presentation. Sean, wow, that was fabulous. Thank you so much. Karina, absolutely brilliant and fascinating. Well, fascinating comes out, doesn't it? Mary, thank you, Pam, for a very fascinating talk. And Petra, thank you, Pam. That was an impressive presentation again. And Jackie, thank you. So clearly presented. I've never understood this, but now I do. Excellent talk. Wow, that's something, isn't it?
Well, good. I'm glad, because I thought I'm going so fast, it'll, people are not going to understand it if they haven't heard it before. But I had to go fast to try and get it all in, But the part that interested me most of all was quantum tunneling. And I think that is absolutely fascinating. And I'm quite sure when they said, this has been seen where a person can disappear and be in the next room through the wall. I know that one can do that in the astral, of course, but in the physical, that's something else. And they said scientific experiments have been done that prove it. Well, that's not something that's going to be told to the general public, obviously. It's going to be something for way in the future. But that was the part that really inspired me to go into it, and to try and learn a bit more about it.
Well, you've inspired other people as well, so thank you very much. Any other last thoughts before we close? So, thank you, Pam, once again. And
I would just like to say thank you all for coming, because I really thought with the subject and that it's going to be so boring and it would be so hard to understand, and I feel sorry for the audience.
No.
So, and I thought I was going to lose my voice, of course, because I had to go boom, boom, boom all the way through. So thank you for being patient and staying. I really appreciate it.
Okay. Thank you, everyone, and thank you for coming. Bye. Goodbye.